Welcome everyone back to Through Inquisitive Kids. In this video, we will be starting our lesson, our topic on the principle of inclusion and exclusion. Now, this is not the basic lesson where I'm going to introduce everything to you because we covered that in a video in the earlier grade levels. So I will be putting the link of that playlist down below if this is new to you. Mind you, I will not be explaining all of the stuff we'll be using in here. Those are all the basic steps. So if you're new to this, again, please go down to the description and watch the lesson and hopefully a few problems and examples from that playlist. Anyway, back to the problem. Mr. Brown is a well-off farmer who is planning to pass on a part of his cattle to his 3 sons and younger brother. In all, he has 2,004 cows, which is a number, each with a number labeled on them, 1 through 2004. He gives all of the cows who is a multiple of 2 to the eldest son, and all of the cows whose label is a multiple of 3 to the middle son, and all of the cows whose label is a multiple of 5 to the youngest son. The rest of the remaining cows are given to Mr. Brown's brother. How many cows does Mr. Brown's brother get? So this is a typical the principle of inclusion and exclusion problem. So we have we know a total, and the total is 2,004 cows. And we're categorizing all the numbers from 1 through 2004 into the categories multiple of 2, multiple of 3, multiple of 5. And you might be thinking, well, we could just find all the multiples of 2, 3, and 5 and give it to the brothers, right? And to the sons. And then we have in the rest of the numbers, rest of the labels, rest of the cows will be for Mr. Brown's brother. Well, you got to think about this. And this is why it's called the principle of inclusion and exclusion. Some of these numbers are going to have overlaps. For example, what about 15? 15 is a multiple of both 3 and 5. Or 6. 6 is a multiple of 2 and 3. And worse, what's a multiple of 2, 3, and 5? 30. It's a multiple of all of them. So how do we deal with numbers like 15, 6, and 30? Well, the first thing we do is to draw a Venn diagram. So it's usually a few circles. And right now we're drawing 3 circles because there are 3 categories, right? We have multiples of 2s and we have multiples of 3s. And I'm going to arrange them like this. Why? Because we need a part to be overlapping right in the middle and 3 other parts around it to show the parts that's being overlapped. Sometimes if you have 4 categories, you're going to need 4 different circles. 5, you're going to have 5 different circles. If you have only 2, then you only need 2 circles. Got that? Yeah, so this is called a Venn diagram. So first, I'm going to call this top circle multiples of 2, multiples of 3, and multiples of 5. First, let's find out the middlemost number first, because when there's times like this, it's easiest to find the middle part first. So that middle part would be the least common multiple. We first have to find the LCM of 2, 3, and 5, which is equal to 30. Then we're going to divide 2004 by 30 to see how many multiples of 30 are in 2004. Alright, so we have 1002 divided by 15 after we simplify that fraction. And over here, we have 6, and that's 90. Subtract, we have 10 left, 2 and 6. So there is a remainder, but the total amount of whole 15s we can create out of 2004 is 66. So this is 66 here, right in the middle. I'm going to erase this because I want to make sure we have enough space. Okay, now that we have 66, let's pick any combination of two numbers. How about 2 and 3? Well, the LCM of 2 and 3 is 6. And what's 2004 divided by 6? Well, if you do the math, it's 334. So I'm gonna write 334 right here. But there is a catch, right? Because 66 was included in here. So don't forget to subtract 66 from 334. And you get 26. 26.8. So over here it's 268. Now we have the same steps for all of the other numbers. Let's do 2 and 5 first. 2 and 5 have a LCM of 10. And 2004 divided by 10 is at most 200. But remember, we have to subtract 66 from 200, which gives us 134. So right here in this blank, we have 134. Now we have the final blank, which is 3 and 5. What is the LCM of 3 and 5? The LCM of 3 and 5 is 15. So we're going to do 204 divided by 15. 204 divided by 15. We get 1, carry that 15 down, subtract, now we have 50. 3 times 15 is 45, subtract, we get 5, and yeah, 133 with a remainder, but the number of whole 15s in 2004 is 133. So right here, we have 133, but we have to subtract 66 from it, giving us 67. So over here, this is 67. So we have all of the overlapping parts right here. And now it's the part where we find all of the rest of these, right? So first, how many multiples of 2 are in 2004? Well, we divide 2004 by 2, and that's 1002. And then that's a total of 1002 right here. But we have to subtract these overlapping parts from it. So first, what is 268 plus 134 plus 66? As you can see, this is all parts of this circle. We add them. Over here we get 8, carry, this is 16, carry, and then this is 4. 468 is this part right here. Now we subtract that from 1002. And also, especially when you're working with lots of addition, subtraction, multiplication, division right here, it's very careful that you really pay attention to what you're doing, because it would be a bummer if you actually had the right solution, had the right idea, but you got a wrong answer just because of some careless mistake that you might have made along the way. So you subtract this and you get 534. So 534, and you're going to write that right here. Now we have the same steps for 3 and 5. First, we can divide 2004 by 3. 2004 divided by 3 is 668. So there's a total of 668 multiples of 3 in 2004. In 2004 itself is a multiple of 3. Now from 2068, let's first add in the overlapping parts, which is 268 plus 66 plus 67. So 14, 21, carry that, 20, carry that, and we have 4. So 401. We subtract 401 right here from 668, subtract that, and we have 267. So over here we have 267. Yeah, so given that there are some cattle with overlaps, I think that Mr. Brown didn't have a very good idea didn't make very good decisions when it came to passing down a part of his cattle because, there's going to be some arguments here, I can guarantee. Now we do the same with multiples of 5. Well, 2004 is not a multiple of 5 because it does not end in a digit 0 or 5, but it's really close to 2000, which is 5 times 400. So we know immediately that there are 400 multiples of 5 in here. Now we have to add in all of these parts. So 66 plus 67 is 134. That is 143, I'm sorry. Now you add these two, and you get 277. So subtract 277 from 400, and you get 123. So over here, this is 123. Now, let's reread the question. How many cows does Mr. Brown's brother get if the rest of the remaining cows are given to Mr. Brown's brother? Well, we know that there is a total of 2004 cows, right? And these are all the cows right here without any overlaps. So first we're going to have to add all of these up. 534 plus 268 plus 134 plus 267. You can do the math. And then you have to subtract it from 2004. So pause the video and try to subtract this yourself. Alright, so after subtracting from 2004, we get 545. So the final answer is 545 cows.